In the next 2-3 minutes, we are going to learn how mathematics is applied in day-to-day life, and I'm going to discuss objective of curve fitting, what is a linear function, one real-world example, conclusion. Okay, first one is the main objective of many statistical investigations is to make predictions, preferably on the basis of mathematical equations. For example, as we approach day to day life, we often need to quantify the things around us, giving structure and numeric value to various situations. Second one is, what is a linear function? A linear function is a function of the form f of x is equal to ax plus b, or what we write y is equal to ax plus b, where a and b are some constants. We know that the graph of this equation is a straight line with slope a and y-intercept b. Now you carefully observe. By taking a day-to-day life example, I am going to develop an equation. Is it possible or not? We will come to know within a minute. As we hop into a taxi cab in Bangalore, the meter will immediately read 30 rupees. This is drop charge made when the taxi meter is activated. All of us know this thing. After that initial fee, the taxi meter will add 15 rupees for each kilometer the taxi drives. In this scenario, the total taxi fare depends upon the number of kilometers ridden in the taxi. And we can ask whether it is possible to model this type of a scenario with a function using descriptive variables. We choose m for kilometers and c for cost in rupees as a function of kilometers, c of m. It means I have defined a function. What is the notation of the function? C of m. How we are going to write down y is equal to f of x or simply f of x. Exactly in the similar way, I have written the function or my own function like c of m. Is it clear? Okay, very nice. Now I will put m is equal to 0 and observe the function, how it behaves. Okay, when I replace m by 0, I can obtain 30 rupees. It means c of 0 is equal to 30 initial fee, as I have mentioned in the earlier. Okay, now I am going to replace m by 1. What I can obtain? I can obtain c of 1 is equal to 30 plus 15 rupees. Totally I can obtain 45 rupees. Why I want to add 15 rupees? Since rupees 15 is added for each kilometer driven. Exactly in the similar way, now I am going to replace m by 2. I can obtain c of 2 is equal to 30 plus 15 plus 15. It means I am going to add 15. How many times? 2 times. That's why I can write down c of 2 is equal to 30 plus 15 into 2. That is equal to, totally I can obtain 60 rupees. When I replace m by 3, I can obtain 30 plus 15 plus 15 plus 15. 3 times. I mean 30 plus 15 into 3. Totally, then I will get 75 rupees and so on. Like that, you can replace m by 4, 5, 6 and so on. Right? So from this, we come to know a pattern. Excellent. What next? From this, we might observe the pattern and conclude that if m kilometers are driven, I will get an equation c of m is equal to 30 plus 15 times of m, because we start with a 30 rupees drop fee. Drop fee means for the first 2 kilometer. So we have paid 30 rupees. Like that we can assume. And for then each kilometer increase, we add 15 rupees. That's why, or in general, you can write down an equation C of m is equal to 30 plus 15 times of m. Here, we want to note that an equation C of m is equal to 30 plus 15 times of m consisted of two quantities. What are those two quantities? The first one is the fixed rupees 30 charge, which does not change based on the value of the input. The second is the 15 rupees per kilometer value, which is rate of change. In the equation, this rate of change is multiplied by the input value. We have already written the mathematical model, I mean equation C of m is equal to 30 plus 15 times of m. Now I am thinking, is it possible to write down the same equation in the tabular form? Yes, it is possible. How I am going to write down? In the first row, I will write m means kilometer. In the second row, I will write C of m means I am function, my function, right? So in the first row, if I replace m by 0, I will get 30 rupees. It means when I travel first 2 kilometers, then I have to pay 30 rupees. After 2 kilometers, if we travel 1 kilometer, 45. Similarly, 2 kilometers, 60 rupees. 3 kilometers, 75 rupees I have to pay. It is important here to note that in this equation, the rate of change is constant over any interval. The rate of change is the same. So far we have obtained a mathematical model, namely C of m is equal to 13 plus 15 times of m, and we have also written a tabular format of the equation. Now we want to think, how do we draw the graph of this equation? It can be drawn x-axis versus y-axis, I mean kilometer versus cost. If I travel 3 kilometer, what is the cost? If I travel 4 kilometer, then how much of amount I have to pay? Then the same thing can be written in the graph sheet, right? Okay, so what is our observation? So we see that the shape is a straight line, which is how these functions get their name, linear functions. When the number of kilometers is 2, the cost is 30 rupees, giving the point 2 comma 30 on the graph sheet. This is the vertical, or we can write down C of m intercept. The graph is increasing in a straight line from left to right, because for each kilometer the cost goes up by 15 rupees. This rate remains constant. Okay, so far in the last 2-3 minutes, we have discussed about a particular example. From that example, what we have learned? We have learned that the taxi cab, a constant modeled by words or an equation or a table or a graph. It is important to note that we will not always be able to find all four representations for a particular problem. And so, being able to work with all four forms is very important. It means you can take any real world problem that can be represented either by words or by an equation or by a table or in the form of a graph. Thank you.